So chapter 1, day 4, box plots. I like what these notes say, but I don't necessarily want to follow them the way they're written. I didn't want to redo them because I like them if you got to look back at it, but I'm not going to follow it word for word. So we're going to do a box plot. We're going to start with, what are two numbers that always describe any data set? If I always say make a graph, what are the two numbers you always pick out? The highest and lowest. So we definitely need highest and lowest. Let me copy some stuff over. All right, so we're going to start with Barry Bonds' home run counts. Put them in order. Go ahead and put them in order first. Just like rewrite it underneath is fine. What's the lowest? Oh, they're in order, aren't they? I wondered why y'all are looking at me. I'm like, put them in order. I don't get it. Okay. Well, that was easy. So they're in order. What else do we need to know? How many of them are there? I don't like the way it's split. So 16, we know that this is the smallest one, this is the biggest one. Two numbers that should definitely stand out to you. We are going to make a box plot. Does anybody remember what a box plot looks like? Raise your hand if you remember box and whisker. What did y'all do in elementary school, like the whole time? Did y'all see math in elementary school? We're just going to stick to what we got. Okay. Y'all are going to realize what it is. Maybe. It doesn't matter if you haven't. They're pretty easy. It says there are 4 ways to measure spread, but there are only 2 listed right here. We've already talked about range. We're going to talk about interquartile range. The root word of interquartile is what? What's the main part of the word interquartile? Quartile. Quart. What does quart mean? 4. We want to take our data and split it into 4 equal pieces. Well, in order to do 4 equal pieces, don't do this. 4 equal pieces means what percent's going to go here? 25, what percent's going to go here? So forth. So how many numbers do I need to be able to split it into 4 pieces? This is where some people are just going to get thrown off at first. I only need these border numbers. So how many numbers is that? 5. So what number is going to go here? In general, yes. Which is the what of the data set? The lowest. What's going to go here? Highest. So we've just got to figure out what are these 3 numbers. Well, if this is 25%, 25% of each one of those, can you think about what that is? So what's here? How much is here? Do we know anything that makes that happen? Do we know a number? The median literally splits it to 50%, 50%. So this is the median. So we've got to figure out what these are. Essentially, it's basically saying we've split it in half, now do it again. We've split it in half, do it again. So on your paper, on the left side, it's the first section that doesn't have bold. It says to construct a box plot, always use the 5-number summary. I would put like a circle, star, or something over there. That's really, really important. You will see that on the AP exam. So order is extremely, extremely important. If I ask you the 5-number summary and you don't give me these numbers in this order, you will get counted off. So 5-number summary is the 5 that we use for the box. Our minimum, our Q1, which we didn't say it's called that yet, the median, Q3, and maximum. Why did I call this one Q1 and call this one Q3 instead of Q2?
Q2.
Because Q2 is the median. So it is the same thing, but just you don't need to split. So let's take our data set and find the median to start out with. So you told me there are how many numbers? 16 plus 1. Let's flip it on the back real quick. I'm going to do something else. I want you to write these. Super basic data set. We've got 5 numbers, we've got 6 numbers in the first one, we've got 5 in the second one. What is the median of the bottom data set? 3. What is the median of the top data set? 3. Everybody's with me there, right? This is the first place where people mess up. I have literally drawn a line up here to divide this half and this half, and that seems pretty easy. Why is that not so straightforward here? Because the line would be on a number, so it's like, where do I put 3? This splits it to where it is not included. That specific one we circled is not included in either half. Even if it were like 1, 2, 3, 3, 4, just this 3 does not get included. So now, what is the middle of this first box up here? And so we're going to call that our Q1. So what's our Q3 going to be? The math behind this is super easy. If these were bigger numbers, technically what do I do with this box? How do I find median? How many numbers are in this box? 3. So what do I do with 3? Plus 1, then divide by 2. Even if there are like 140 numbers there, you're looking the same way. So the only thing is, if you circle a number, that one's not included in either box. So here, our Q1 is what? And then our Q3 is going to be so if your median actually is a specific number, it's not included in either half as far as determining your quartiles. If I were you, I might mark out these numbers on the bottom and then rewrite them over here so it's a straight line, just because that's how I would want to see it. I don't care what we do though. So we said 16 numbers, so what do I do with 16? Plus 1, 17, 17 divided by 2 is 8.5. 1, 2, 3, 4, 5, 6, 7, 8. So we're splitting here. So our median equals what? If it's between 2 numbers, you add them up, divide by 2, but those are the same number. So now how many numbers do I have in this front box? 8. 8 plus 1 is 9. 9 divided by 2 is? So what is our Q1? The math that you did here with the 8 plus 1 divided by 2, darn well better be the same math you do here, otherwise you did something wrong. If you have different numbers in different boxes, you've done it wrong. So we're still going to between 4 and 5. So now what is my Q3?
Wait, and how did you get the 41?
So same thing, 8 numbers.
Yeah.
8 plus 1, 9. 9 divided by 2, 4.5. So 1, 2, 3, 4. And I should have said this more last week. I teach a class like you understand everything that I'm saying. And if you guys all keep doing this, I'm going to keep going at my pace, maybe faster. I don't do it that way because you should know everything I'm teaching. I do it that way so that there's no reason for me to spend 5 minutes on something you're like, we know how to do this, keep going. So I teach fast for you to purposely stop me. So if you don't get it, stop me. Slow me down right then. I don't care. I'm doing it that way on purpose. So I go at a pace, but we can slow it down if we need to, and that is absolutely fine. All right, everybody with me so far? Yes. Yeah, go ahead. So 5-number summary. The first one is going to be what for this data set? 16. My second one is 25. 73. So if I said what is a 5-number summary, you could write 16, 25, 34, 41, 73. That would be the answer. All right, so now we're going to make a box plot. I think I drew a line for y'all just so you have something as reference. I am going to eventually include both graphs on there. I just don't have it on there yet. It doesn't matter yet. So in saying that I know I'm going to have both data, this is a number line. I want to make sure that I at least include the lowest, which is 13 down here from Hank Aaron's, and at least 73, which is the highest for Barry Bonds. Just like making a graph that drives me insane where people write something on the y-axis like 16, 19, 24, 25, you absolutely should not do that here either. The only things I need to know are highest and lowest, and make sure I include both, and make sure I go by equal intervals between. So if I have to go all the way down to 13 and all the way up to 73, I'm probably going to start at 10. I don't know how my spacing's going to do. I'm probably going to end up going back by 5s, but I want to do the spacing.
Where are we using it?
I'm just picking one. Because I need to make sure that I include everything. I need to go up by an equal interval. And I'm just kind of thinking about what would cover it. Yeah, so just like you number on the y-axis of a graph, usually like you get picked, same thing here.
But why are we doing the number
line?
That's how you need the dots.
Yeah. Yeah. So everybody good with why I picked those numbers? Yeah.
Are you graphing that data set or the bottom one?
I'm going to graph the first one. I'm just thinking, like, eventually we're going to put them both on here.
Okay.
So you would need to know that, though. Otherwise, we'd have to go and add stuff in. All right, so I've got my number line. I want to graph these. I want to start with, and you don't have to go in this order. Your number line should not overlap with your box plot because otherwise it's hard to read your box plot. So your box plot is kind of like floating up here. So it's called a box plot or box and whisker. So we're going to draw the box first. So the box is this middle section here, which is what percent? All the way from here to here is going to be what percent? 50%. So we're drawing a box for the middle 50%. So we want a vertical line at 25. A vertical line at 41. About same height, same length kind of thing. And that's going to make my box do better than I did. So that's the box, that's the core, that's the middle 50%. Then we have have one more vertical line that is our median. So that's the box, the core box. We've got 25% here, 25% here. That's our middle 50%. Now,
What's the line in the middle? The
median, yeah.
Is it supposed to look like it's in the middle? Or
It depends. Like, it should look on the number line where it is. Where it is closer to one of the others, it's going to change the shape. We'll talk about. Now, the other thing we have to deal with, so if we're going to do a 5-number summary to describe it, we want 5 numbers on the graph, but I only have how many right now? 3. Which 2 am I missing? The what and the what? Highest and lowest. So the highest and lowest are each going to be a dot. So about 16 here. Some people do like literally a dot. Some people do stars. Some people don't do much of either one, and that's fine too. But I'll explain more in a second.
and then you connect it.
Not yet. Sometimes we connect it and sometimes we don't. Which one of those looks odd?
Sorry, right?
Because we think it might be a what? An outlier. So let me explain to you how we actually do this theoretically before we do it mathematically. This box right here is everything that we're basing it on. So we want to see if this, not just that this dot is so far away, but this dot is so far away in relation to this. So how many boxes is that low dot away? About half. So here. How many boxes is this dot? Was this dot away? A little more than 2. So we have to decide, well, what does it mean? Like, when is our number of cutoff? It's 1.5 of these. So anytime it's more than 1.5 of these away, that's what we're considering an outlier. Flip it on the back. Because I want to make sure we have enough room to write that. I'm going to say general checking for outliers. I always do it like this, like a question, because we don't know if it is or isn't. We're kind of seeing what the cutoff is. I don't care if we put a question mark or not. So you're going to tell me an equation based off of what I just told you. So with what I just told you, when I was checking that way, where did I start my green boxes? I started measuring by green boxes at what? Which is the what? What is this?
Q1.
Q1. All right, so we know when I'm checking for a low outlier, I'm starting at Q1. If I'm checking for a low outlier, which direction am I checking from Q1, left or right? Left, which mathematically means what? So, what did I subtract? What did I say that it was going to be in relation to the boxes? And right here, don't write this. We're in agreement with that, right? But that doesn't seem very mathematical right now, so we've got to figure out, okay, what is box? Interquartile range. I think there's more of this written on the front. Flip it back to the front. It says interquartile range is the range of the middle 50% of the data. It's number 2. Sorry, I'm right up here. It says IQR equals Q3 minus Q1. So it's basically the range of that box. I like things to stand out on my notes. I would probably rewrite IQR equals Q3 minus Q1, like in this gap. Just to me, like that's something that stands out. It's on that paper. If you're okay with it, that's fine.
Write it again.
That's just me. I would want important things to stand out. So instead of putting box here, what is actually represented by the box? IQR. And then I'm just going to write anything below is outlier. So I have to check for it on the low end. I also have to check for it on the high end. So when I check for a low outlier, I'm not starting at Q1 anymore. Now I'm going to start at what?
Q3 plus 1.
Because I want to go to the right now instead of the left. And I still 1.5 boxes is what I'm checking. Yeah. And any above is outlier. So can there be more than one outlier? Yes, because anything that's above this number, above that number would be, anything below this would be. So there could be more than one. I don't think there's that much room on the front. I would probably continue this on the back, just label what you're doing. So this is Barry Bonds outliers.
What is very low?
The data that we're dealing with is up top. So when I check for low outliers, I'm going to go ahead and write, because I'm showing it like I would do on a quiz, Q1 minus 1.5 times IQR. Some people are going to do this step a little bit different. Some people are going to find the IQR and then write it down and then multiply by 1.5. Some people are going to multiply by 1.5 earlier. Usually it's going to be a question on your quiz also, what is IQR? So our IQR for Barry Bonds, what is our Q3? What is our Q1?
25.
So what is our what is our IQR? Alright, so now I'm just plugging in numbers. What's Q1?
25.
Minus, so this is where some people are going to write 1.5 times 16. What's half of 16? What's 16 plus 8? So some people are going to write 24 there, and some people are going to write this, and I don't care which way you do it. So 25 minus 24 gives me what? And now I want you to do something other than just stop there. This is extremely, extremely shorthand. There are no outliers that are low outliers because there are none below that number. Like I have justified everything. I knew that I'm checking this number. I knew that I'm checking the direction below. There are no numbers that are below. So we're checking to see if there are high outliers. I'm doing Q3, what? And so because this 1.5 times IQR is the same here as it is there, that's why some people just go ahead and do it initially. I don't care. What's my Q3 number? And 41 plus 24 is, so what number is an outlier? And that's the only one, right? Some people put something here like greater than 65, less than 1, instead of writing it like that. As long as you're conveying the fact that you are checking for this. You're checking for this. I don't care if you do that or write it, whatever. Alright, so we definitely have justified 73 as an outlier. So what was really important about wording with outliers that I talked about yesterday and with the homework?
They have to
Appear. So now, can I check to see if it is or isn't? So now, if you said appear, I would count off for it. And I'll eventually tell you there are examples to where I can give you information and you still have to say appear because you can't physically calculate it. We'll get there. So this one is an outlier and that one's not. So this one's really far away. That one's pretty close. So you were going to tell me I need to do what next before I start talking about outliers. Connect it. So this one's really close, so we go ahead and connect it. So it's not an outlier, so we connect it. And that's why it doesn't really matter to draw that star. Like if I don't have the star there and it just goes to an end, that's fine. But now I have to decide, well, what about this one? And this is probably the most common mistake with making a box plot. I know that anything above 65 is an outlier. And 873 is definitely above 65. But
Can we not just add 16?
what?
Can we just add 16?
No, you don't want to do that because you want to show that it's an outlier. So anything to here, anything below here is not an outlier, but if I drew the line all the way out to here, that would make it look like what? It looks like they actually have that many, right? So you only do it to the highest number that is not an outlier. So this horizontal line is only going to go out to what? So just showing you where it is in the front. Flip back to the front real quick where it says step number 4. And it says, oh, you're on the front. Draw lines from the end of the box to the smallest and largest values that are not outliers. I would probably underline or something that. Like that's probably the most common mistake when graphing these is the largest ones that are not outliers. But it needs to be something in the data. So do not do it out to 63, you're doing it out to 49. So let's very quickly, briefly go back to socks. I'm going to skip shape right now. Outlier would be what? Yes or no? Yes, there definitely is an outlier at 73. So in context, that means what? There was one context.
Uncharacteristic.
Context.
One of one.
It might not be that descriptive, is it? What do you think that represents? Do you think he had 70-something home runs in one game? Season. So there was one season where he had uncharacteristically high amount of home runs at 73 relative to his other seasons, and none where he did uncharacteristically terrible in relation to. Again, with the star thing here, if you do stars, some people put one here, whatever. That doesn't really matter. Does anybody know anything about Barry Bonds? You are getting. That year he got in trouble with
Did he use steroids?
yes, he got caught that year with steroids. They probably had a lot of data to support the fact that maybe they should check it out using statistics. All right, center. Obviously, which one are we gonna go with for right now? Which one did we find? Median. So the median is 34, which means about context. The median is 34, which means that about
half the seasons he got fewer home runs and half he got more.
about half he got less than 34 home runs per that season, and about half he got more. Spread for now we have two options. So if I just talked about range, well, it's 73 and 16, so what's our range there? What's our range there? 57. So the season where he scored the most was 57 more than the season where he scored the least. Does that seem like a very good description of him overall? Because that one out there is so different that maybe that's not the best description of talking about how consistent he is. So interquartile range is something that we can also use a spread, which is this part, this box. Our interquartile range was how much? We calculated this already. 16, which means the middle 50% of his games, or middle 50% of his seasons, his home run count was within 16 home runs of each other. Does that make sense? And again, I'm throwing a lot at you. We'll come back and write it all in detail, but I need you to be able to follow. All right, so what's the one that I skipped? Socks, what did I skip? Shape. That outlier is going to throw off a lot. So sometimes we talk about shape, we say excluding the outlier, and sometimes we say including the outlier. If we said including the outlier here, maybe what would you say the shape would be? Let me not talk about that. In each section, what do I know about each section? 25%. I'm purposely trying to draw this box plot to where each section is about the same size. How would that look in a graph? Maybe.
It would look uniform.
This one would probably look fairly uniform.
Because it has that outlier out there, does it make it right?
I would probably say more right skewed. What about this one?
It's symmetrical.
Because when we do symmetrical, we're doing this half to this half, right? That's fairly symmetrical, even if I did it backwards where these are big and these are small.
Right.
And sometimes this throws people
Wait,
off.
I think it left.
That's where people get thrown off sometimes. So 25% is here, right? 25% is here. So this section looks really small. But what does that mean about the number of individuals here versus the number of individuals here? So we've packed a whole bunch in here. So if we were talking about it like bars, would these be tall bars or short bars? So there's a bunch here, but not much here. So what is the shape of this one? And you have to be able to think through it that way. So like sometimes I have to mentally be like, okay, that means there's a bunch here, but these are smaller. And I'm doing a very terrible job. But to me, I'm thinking, okay, stack a whole bunch versus spread them out. Here I'm stacking a whole bunch again in the same. So that to me is kind of how I can think through right skewed a little bit more. But some people do get that confused. Because a small section means there's a whole bunch packed in there, which would mean like tall bars on a graph. So our example, I would probably say, this was kind of vague. I would probably say Without the outlier, it's what? And this one is vague, so y'all might say different things. If I'm not including this at all, what would you say this shape would be? What?
Slightly less.
Maybe slightly left skewed, maybe what? Fairly what? It's fairly symmetrical, maybe slightly left skewed. If I included the outlier, I might then say what? Maybe right skewed. So some people are going to say fairly right skewed, fairly symmetrical, excluding the outlier. Or some people might say, including the outlier, the graph is right skewed. So different answers are still going to be correct. You can talk about it both with and without the outlier, especially if there's one that's that extreme. Let's stop there for now. If I don't tell you any different, part of your homework is going to be do all the math to be able to draw the graph for Hank Aaron, like checking outliers, find the quartiles and stuff.